In middle school, you were supposed to have an introduction to the periodic table. So what this is a review of what you should have already learned in middle school. And it will help you to understand some of the terminologies and maybe a little bit of the history of the periodic table and how we organize our elements. Periodic refers to something that occurs at regular intervals, such that you can actually predict what happens comes next if you know what has come before. So for instance, the sun comes up every morning, or at least it looks like it because the earth is rotating, and every year certain festivals occur. So those are periodic things. They occur at regular intervals. Most of the time we think of periodicity, periodic behavior, as being something that is measured against time. But that's not the way we measure the periodic properties of the elements. What makes the periodic table periodic? Well, Mendeleev said it's the atomic mass. This was mid-19th century. He said that every few atomic mass numbers, properties, repeat. He was close to being right, but he wasn't completely right. What makes the periodic table periodic is different because when they measured very carefully the atomic masses of all the elements, they found that in the case of tellurium and iodine, the average atomic mass of tellurium is actually larger than the mass of the element iodine on the right. And yet tellurium has chemical properties like selenium and sulfur, and iodine has chemical properties like bromine and chlorine. We of course arrange the periodic table so that elements with similar chemistry are on top of each other, or in vertical columns. So Mendeleev was close, but he wasn't exactly right. Moseley came out and found, with his very, very careful scientific work that you can research on the internet or in books, he said something different in 1913 because he knew something about the structure of the atom. He said that it's atomic number that determines the periodicity. Periodic properties are a function of the atomic numbers. Unfortunately, he was killed. He was drafted into the British Army and sent to Gallipoli and was killed in 1915. They managed to kill, or have killed, the best scientist of that generation in England. We refer to the term period as all of the elements in a horizontal row on the periodic table. For instance, this is one of the periods. This is the period that begins with potassium and ends with krypton. That is a chemical period. Remember, the chemical properties in a period are not the same. A group, or family, constitutes all of the elements in a vertical column, and their chemistry is similar. So, group 1 of the periodic table, lithium, sodium, potassium, rubidium, cesium, and a very radioactive element called francium, they all have similar chemistry. For instance, they all react vigorously with water, and certainly with acids. Now, if you don't mind, we're going to sing. And this is the way I'm going to teach you the families of the periodic table. Group 1, the alkalis, are good conductors. They react with water and air, and they're shiny when you cut them. This is called group 1 or 1A in some ways. The alkaline earth metals, group 2A or just 2, are harder and denser than alkalis. They're very hard to cut. They conduct electricity like all metals, and you might want to remember magnesium and calcium as good examples of the alkaline earths. The The transition metals constitute the center of the periodic table. They tend to be hard. Many of them are colored. They form colored salts, especially in water. They're good conductors of electricity. If you look, and you'll see copper, for instance, and silver, excellent conductors of electricity. These form less soluble salts. The alkali salts are always soluble in water. Many of these salts are not soluble. These are columns 3 through 12 on the periodic table as we have it. There is a line, you'll see it kind of as a jagged line running down about 2/3 of the way to the right in the table. I've just put a regular purple line there. The metals of the periodic table are on the left. There are a lot of them. They conduct electricity. They're ductile. They can be drawn into wires. They're malleable. They can be hammered into sheets. These are metals on the left. The left is for the metals. The nonmetals are on the right of the line. There aren't as many of them. They do not conduct electricity. They are electrical insulators, and they tend to be very brittle, or in many cases, like oxygen, fluorine, chlorine, they're actually gases. Bromine is a liquid and iodine is a solid. And this last part of the periodic table, helium through radon, constitutes gases that typically do not react at all. That second to last are called the halogens. The halogens combine with metals to form salts. As elements, they are very, very poisonous. They're very reactive, which is one of the reasons they're very poisonous. They'll react with the tissues of your body very handily. But when you turn them into salts, like sodium chloride or potassium bromide or lithium iodide or copper chloride, they don't react very well. They're kind of in a low energy state. And as elements, they come in packages of 2. We say they are diatomic elements, F2, Cl2, Br2, I2. We've talked about the elements that don't react very well. These are called noble gases. They used to be called inert gases, but when I was in school, they started discovering that some of them will actually react and form, say, compounds with fluorine. You may have seen these used in illuminated signs. Some of the older types of signs before we had LED signs had tubes with the gas in them, and they passed a high voltage through them and got colored light. We're actually going to be doing that in the lab. The structure of these noble gases, their electron structure, will be very, very important to us later. So here is the periodic melody. I apologize for the text. The tune is familiar to you. Mendeleev was very great, ordered stuff by their weight, properties repeat by 8s on his table. 8 elements separate elements with similar properties. Like reactions up and down, up and down, up and down, like reactions up and down when they're able. If one element in a column reacts with something else, chances are excellent that every element in that column will have similar reactions. Alkalis are very soft, don't put them in your loft. They react with H2O, great conductors. The alkali metals, that's group 1 or 1A, have electrons that are kind of loose, and they'll move and they'll conduct electricity. And also they react, so you can't hang on to these things. Halogens are colorful, please don't breathe or you'll croak. Diatomic elements, they're no fable. Chlorine, fluorine, bromine, and iodine are very reactive. They react with metals, with water, with hydrogen. They are just plain reactive. Iron and nickel, gold and zinc, waterlogged, all will sink. Silver, copper make good wires or long cables. I say there's more to this wonderful ballad, but A, it's not wonderful, B, it's not a ballad, And C, I haven't written anymore. I guess you're all very, very happy about that. You do need to learn some more chemistry, but this is enough to get you through the next few weeks.